Good morning, everyone.
This is what we have created yesterday. We can see that we have a region, and within the region we can see that we have the VPC, and within this VPC we just created the availability zones. In that we can see that we have a public subnet and private subnet, and inside this public and private subnets we created two instances, and we created the NAT gateway. Uh, And also we can see that we can, we have created internet gateway and we have created NAT gateway. And the complete setup it is done. And it is we also created two instances inside in public subnet we created one instance and private subnet we created one instance. I explained that what is meant by best in host yesterday. Best in host, which is basically works in a public network. Whenever you want to connect the private endpoints, which is running in the private subnets, we usually use this particular best in host. That is where we had to go for something it is called as a best in host. So we just need to understanding about like how we just know, and we just need to send request from the best in host to inside the private subnets. That's what we gonna discussing about like in today's session. And let me log into this my AWS account. If we go to this EC2 instances right now, look at my screen. Yeah, we can just look, if I just go back to the instances, and we can see that we have something it is called as a best in host. The best in host has a public IP address. And if we just go for web server, we can see that this is a planning where we wanted to deploy the application. We can see that it doesn't have public IP address. So we know that like if it doesn't have a public IP address, we can't able to expose to the internet. That's what exactly we are trying to discussing about it. So the first we have to go for the instances right now. And let me try to connect the first best in host. Okay, click on the connect. If we go to this, click on the instance ID. Yeah, and I want to see that what is the key pair that we have given for the best in host. And if you just look, this is a key pair that we have given Clahan hyphen best in host. And what is the key pair that we have given for the web server? That is also we need to check. Yeah, so we can see that this we have given a Clahan hyphen web server. Okay, that's fine. Now let me first connect the best in host. Mm, Go with the appearance. Click on the change, and we just need to go for the tool here. Go to the connection. I just need to provide the 60 seconds and go to SSH and authorization, credentials. Click on the browse. We just need to provide the um, yeah, this is the one. So click on the accept. Now this is my server. Let's say I'm just gonna become the root user. Now here Let me just draw the diagram so that it is easy. Yeah. This is nothing but like we have one server which doesn't have the public IP address, and we have something it is called as a best in host right now. This is nothing but like my best in host. Okay. And here is nothing but like my private, what we can say about like it is a private subnet. And within the private subnet, we can see that we have the web server. Now, from this server, from this server, we have to connect this instance from the best in host. We had to uh, make a connection. That is what we should understanding about like what is meant by the best in host. See, we have to, we just need to send a connection request from the best in host to web server. That is what exactly we are just going to make the connections. So once we have done right now, let's see that how we can able to do that. The first we can just, we have to go there. Now, whenever you want to connect this first, we just need to, we need a key pair, right? We need a key pair. That key pair, yeah, that key pair, uh, we need to create in a the business host. Okay, that's what we are gonna do that. Let me just go there. And what is the key pair we have created? The same key pair we had to copy and paste inside the server. Let me just go to downloads. The key pair name, one second. This is a web server, right? Let me just draw there. We had to go for .pem. Okay. Escape colon WQ. We have to copy and save. And after that, we just need to go there. We have to execute this command. Chmod. One second. Go to chmod. And after that, we can just look at here. We just need to connect this server. Yeah, we have to mention yes. See, from the public instance, we connected the private instance. If you look at very carefully, and the best in host, whatever that we created, it is Amazon Linux machine. If you observe that, you can see that this is the instance what we have connected first from Amazon Linux right now. From the Amazon Linux machine, I connected the Ubuntu vision. Ubuntu is nothing but like my web server, which is running the private subnet. Is this is clear how I did it?
Can you help why we're doing it? Sorry.
I hope you guys are understood this one.
Muli, can you explain as to like why we are like connecting the bastion host?
I
Yeah,
said very
pretty much.
clearly, whenever you're trying to creating any instance in the private subnet, if it
Okay.
doesn't have the public IP address, how can we access the server to the internet? We can't able to access any server to the internet if doesn't have the IP address, public IP address. You getting my point?
Okay, okay. Yeah, yeah.
Now, the web server doesn't have the public IP address because it's working on the private
Mhm.
subnet.
Exactly. Okay, okay, okay.
Anything which is running on the private subnet, we have to connect from the business host. That's what my point from the beginning.
Gotcha. Okay.
So any EC2 in public subnet can be a Bastion server to play
No,
that role, is it?
not any instance which is running in a public subnet. What about others? Why you guys are silent? Could you please confirm so that we just move on next?
Yes, Murli, we can move on.
Okay. Now we can just look at my screen. We have the we have done this particular the connection, and after that, what we have to do is I just need to first go back to the root user, and after that, inside this server, I want to deploy the application. Once we deploy the application, if it doesn't have the public IP address, how we can able to access to the web browser? That is my next question. Okay, let me show you that. The first we had to become the root user. Okay. Now, once you become the root user, after that, what we do, I just want to become the, I just want to become the root user. Let me just try to install a web server and I can deploy the website application inside the web server. So we know that like we have experimented and how to convert the instance as a web server. The first we had to go for the apt-get and install, and we have to mention about like which web server that you are trying to install that. I'm just trying to installing the Apache 2. It is nothing but like my web server what I'm just trying to installing. We can see that apt-get install and Apache 2-y. So once we hit the enter, we can just look at my screen and we are just trying to installing the Apache 2 web server. Yeah, once you've just created the web server, after that, what we have to do, I just want to go to inside the var www.html directory where I just wanted to copy the the code. So first, I'm just trying to clone the code from my GitHub repository. Okay, let me just go there, go for the GitHub and go with the repositories now. This is nothing but like my where we can say that the Flipkart clone application that we have created, right? I'm just trying to creating right now. Let's type the command called git clone. And after that, we can just see we are just cloning the repo here. Sorry, type the ls command, the cd space, the Flipkart clone. Here, if type the ls command, you have the everything, whatever we have. Let me just try to copy that inside the server. So first we had to go inside the folder. After that, we have to use the copy command, -r dot forward slash where go to www and HTML directory. This is the directory where I just trying to copying that all the files into the directory. And if you just check the status of the server, I'll just go for the service. And after that, we have to go to Apache 2 and we have to mention about like status. We can see about like it is active and running status. That's what exactly we are gonna discussing about right now. Okay, so this is what exactly we are gonna do that right now. So once we have done these options, now what we can do it, I just need to go ahead. I just need to copy that everything inside the var HTML directory where we are just copying all the files over there. Now we want to export the application to the web browser. Now, if we want to export the application to the web browser, we can see this is where we had deployed the application, the web server. Go back here, the instances, and the instances we can see there is a web server, there is an instance ID, and we can see about like we don't have a public IP address. Now the question is like how you guys can expose the application to the web browser. Yeah, make it fast. Anyone have any idea about it?
Private subnet EC2, isn't it?
That's what Friday submit instance. Yeah, make a note this point. This is very, very important. Uh, when any application we deployed in a private subnet, if you want to expose through the web browser, definitely we need a load balancer. This is a point that you guys has to understand. See, whenever any server that we created in the private subnet, once we deploy the application in the server, you won't expose the web browser. The web browser, web browser, definitely we had to create this buckler. Definitely we had to create this load balancer. Without creating load balancer, we can't able to expose anything to the internet. So this point is very important. You just make a note and remember when we are discussing about like Kubernetes, that time definitely these points are going to help you very much. So this is something that we are trying to understand. So let's go back and we'll see about like how we can able to setting up the load balancer. So whenever we talk about the load balancer, we should understand about like what is exactly mean by load balancer and how we are going to understand about the load balancer. See, load balancer is very, very important. In the beginning of the session, also I explained about like what is the importance of the load balancer. See, any application that you access to the internet, you go will Flipkart application, you go to the Amazon application, you go to the Alibaba.com, what are the applications that you are trying to access? Definitely the request going from the local mission to inside the load balancer. I mean to say whenever you send the request first will go to the load balancer. From the load balancer, it is go to a particular server. So what is this job of the load balancer basically? Why do you wanted to create a load balancer? That's very, very important. So let's say, for example, this is nothing but like my user, right? This is nothing but like my user. So whenever the user get the request, or we can see about like whenever the user send the request is always first go to that load balancer. So why this particular load balancer we have to understand. See, load balancer is nothing but like it is going to accept the incoming traffic. See, whatever the traffic which is coming towards the mob application, the first request will go to the load balancer. Why? Because load balancer has two responsibilities. Load balancer is basically to distribute the traffic between the servers. Let's say in our case, like we have the only one server, but in production environment, there are multiple servers that we have. So if we want to distribute the traffic between all the servers, definitely we have to go for something it is called the load balancer. That is where we have to understanding about like what is exactly meant by a load balancer. See, this load balancer is basically distribute a traffic between the servers. So it is main responsible load balancer is it is going to accept the incoming traffic and it is going to distribute traffic between the servers. That is a major we can see about like that is a major idea about like why we require something it is called as a load balancer. Let me just first see, let's say this is nothing but like my server where we have right now. So the first request go to load balancer and the request will go to this particular the server right now. So the first the responsibilities of a load balancer is load balancer is all about distributing the traffic. So let's say, for example, you are getting the multiple requests. You are gonna some like getting some lakhs of requests, right? That time, how we can is going to handle all the requests. If I'm gonna send all the requests to a single server, definitely a server it is going to be crashed. That is the reason if there is something it is called a auto scaling that you implemented, when automatically that new server is got created, I want to route the traffic to the different server also. So that is where we should understanding about like what is exactly meant by load balancer. The load balancer, the primary responsibility is going to accept the incoming traffic and distribute the traffic to the different servers. That is the primary responsibility of load balancer. See, why we have very confident about the load balancer means load balance before it is going to route the traffic to the before it is going to route the traffic to the server, it is also going to check the health of the server. That is the reasons. So if we ask like Murali how it is going to create the or how it is going to check the health of the server means, so it is going to check the health of the server based on the ping request. See, for example, how can I say that from the one server I'm getting this particular response or not means we have to send the ping request, right? So I'm just let me just show you that. Let's for example, if I go for the command prompt. I'm going to say let's go for the Windows PowerShell. So any website that you ping with help of the ping command, we can see, for example, if I'm just use a ping command, www dot, and go for the we can see about like we can just go for the google.com right now. So once you hit the enter, we can see that you are just trying to ping this particular the google.com. We can see that you are just getting the reply from the 142 dot the 250.77.100. This is nothing but like my IP address, what I'm just getting. We can see that the number of bytes, and also we can see about like time 12 minutes or 12 milliseconds. Also we can see about like TTL. See the packets that we have sent 4 and the packets that we have received is 4, and we can see about like we are going to lose the 0%, right? This is nothing but like what is the complete the packets that whatever that we have. So we have sent 4 and we received 4, and we can see about like lost. We just need to understanding about like 0% loss. This is something that we should understanding about like what is the replay from and how we are trying to accessing this particular server. So anything like if you just go there, if you type the command called as a the ping space www dot and go for the flipkart.com here. Now once you hit the enter, we can see that you are just trying to access the request. We can see that the maximum And we can see the received sent 4 packets or received 4 packets. We can see about like 0% loss. This is something that we should understanding about like how this ping request is gonna work. See, with the ping request, it is going to check the or it is going to check the health of the servers, whether I'm able to getting the response or not. Yes.
Uh, a small doubt, sir. So the route table is what that defines how the network traffic is routed within a VPC, right? But and the load balance is different because that kind of
Yes.
distributes incoming
Whenever you
traffic
wanted
across
to,
multiple
I got
sockets.
your question. So whenever we talk about the route table, see, whenever you send the request has to go to the route table. From the route table, the request has to go to the server, right? This load balancer,
Yeah.
it is going to act as a gatekeeper. Whatever the request coming towards your application, it is going to go to the load balancer. The load balancer will accept all the requests. It is going to send to the server. See, when I say something, it is called sending to server means it will not directly send to server. All the networking configuration come to the picture. The route table and the NAT gateway, the internet gateway, that whatever that we discuss, the complete setup comes to the picture. You getting my point?
Okay. Yeah. Yeah. Now
Yeah.
I'm understanding. Okay. Thank you.
So where it will sit in that bigger picture, like if you go back to the picture subnet, public and net, where would the load balancer be there?
In a bigger picture, if you go to the bigger picture, if you go to anywhere, definitely this is going to be sitting in the private. So whenever you have something, it is called private subnet. You won't expose anything to the internet. Definitely we require load balancer. There is no other alternative. There is nothing to worry about it. Even if you have the 100 servers are there, 100 microservices are there, you deploy 100 microservices in different containers, which you deployed in Kubernetes. You want to expose again, we had to go to load balancer. So load balancer concept is everywhere is same.
No, my question is, could you have it after the net, before the net, or after the internet gateway? Where does it actually, or do we have it multiple places?
Which one?
Load balancer.
Sorry, come again your question.
My question is, load balancer sits where? I mean, in our picture that you created from internet
Still we have
gateway.
not created, right? Just wait for a minute. I'll explain that where it will sit. Okay. Uh, yeah. We can see that the first we should understanding about like what is load balancer, and we'll see about like how it is gonna create it. The first we can see that the load balancer accept the incoming traffic from the clients and route the request to the EC2 instances to the target missions. That is what is the job of the load balancer first. So next we can see that the load balancer is also monitor the health of the restart targets. So because see, if I have the 2 servers right now in my production environment, let's say for example, I want to distribute traffic between these 2 servers. So whenever the first request go to my first server, see before it is going to send any request to the server, my load balancer it is going to check the health of the server. So how it is going to check the health of the server here? I explained that it is going to check the health of the server because if my server is unhealthy, if my load balancer send the request to server, then my customers will not get the response. So then they feel that application downtime. That is the reason load balancer is always watch the load balancer is going to be always watch the what we can say about like health of the server. It is going to monitor the health of the server based on the ping request. I'll show you about like when I'm trying to create a load balancer, and I'll show you about like where it is going to how it is going to create it. Now, if you just look at my screen, right now it is going to check the health of the server. If the server is healthy, if it is getting ping request, if the ping it is working, if it is getting response to request, then this particular request will go to the load balancer, right? Now once it is go for the request, it is going you are going to get the response. That's where we are trying to understanding about the how the load balancer we have to create it. So look at there's only 2 points. The first one, it is going to accept the incoming traffic from the clients. It is going to route the request to the EC2 instances, and the second point is nothing but the load balancer is also monitor the health of the registered servers. Then when I say about targets, is nothing but like EC2 instances or your servers, what you are trying to configure or what you're going to attach to the load balancer. Okay. Now it is ensured that this route the traffic only to the healthy targets. It is going to route the traffic to only healthy targets. See, when the load balancer detects unhealthy target, it is stop the route traffic to that target. See, when the server it is going to be unhealthy, it won't send any request over there. That is where we have to go for something it is called as a that is where we have to understanding about like what is the responsibilities of this particular the options right now. See, when the load balancer detects unhealthy targets, it is going to stops the routing the traffic. And once it is going to be start the routing, so what will happen, it resumes the routing to the target, then it is ready, the target is healthy again. So once again, it is keep checking about health of the server. If the server it is going to be active status, then only it is going to send the request to particular server. That is a primary how it is going to work once again. So this is something that we should understanding about like what is meant by a load balancer. Now here we'll see about like how we can able to configure the load balancer. When you're trying to configure the load balancer, where we have to configure, that's very important. Now, whenever you're trying to creating a load balancer, you have to create in the public subnets. Load balancer always sits on top of the public subnet only. So whenever you wanted to create load balancer, definitely we need something it is called as a two subnets that we have to create it. Now let me just show you about like how to create this particular load balancer. So whenever you want to create a load balancer, first what we have to do, we have to go to your dashboard. In the dashboard, we can see that we have the option name it is called load balancer. Yeah. So when you just go for the load balancer, and after that, we can see that as of now, we don't have any load balancer. See, in load balancer, there are two types of load balancers that we have. One is nothing but like you have the, yep. So one is nothing but like you have something, it is called as a L7 load balancer, and we have something, it is called as a L4 load balancer. Now, as of now, you just remember and understand that we are creating something, it is called as a L7 load balancer. L7, nothing but like, application layer. We discussed in the beginning from the classes what is meant by L7. L7 is nothing but like, application layer. And we are creating a load balancer, L7 load balancer, because L7 is always going to listen the HTTP and HTTP request. Now our application listens the HTTP and HTTP request. That's the reason we are just going to creating this load balancer on. This is where we are trying to creating. So let me just try to create it right now. Let me just go there. Click on the create a load balancer. So when you just click on the create load balancer, we can see that the different types of load balancers that we have. We have the application load balancer, we have network load balancer, we have gateway load balancer, and I can just go there. We can see about like there is nothing but like we have these particular different load balancers that we have, right? So application means L7, network load balancer means L4, and it is nothing but like gateway load balancer. Whenever you wanted to route the traffic to different APIs, definitely we had to go for the gateway. Now this classic load balancer is going to provide by the AWS. It's going to act as a L7 load balancer. If we come down, we can see that classic load balancer, when you have an existing application running in EC2 classic network, then we had to go for the classic load balancer. Now click on the create here. See, whenever you are trying to click on the create, it is going to asking about like what is the basic configuration, what is the name of the load balancer that we need. So we can see that the load balancer name, I'm just trying to mention about like the Clahan-LB. That is the load balancer that we are trying to creating. We can see this is what is the scheme that we have to understand. What is the scheme right now? This is nothing but like internet facing. See, traffic where it is coming from. The traffic is always coming from the where? Internet. That is the reason we have to select something it is called the internet scheme. And we can see there is something it is called internal. So because we don't get the internal traffic, we are going to get the traffic from the external, from the internet. That is the reason we have to go for the internal facing, right? Now, this is very important. Listen to me. The networking is very important. Where you are trying to creating your load balancer, that's very important point that we should understand that. You have to create a load balancer on the specific network This is nothing but like Clahan-VPC. That is what we had to go for the network mapping. See, we are trying to creating load balancer within my VPC, what we have created. Now we can see that two availability zones that we have. So in the two availability zones, we have to select where it is your public subnet. So we have AP-South 1A. Here we have created one public subnet. See, if we go to this AP-South 1B, you don't have this particular private subnet. See, it is clearly telling that warning, the selected subnet doesn't have the route to the internet gateway, because I clearly explained that load balancer has to be create in the public subnet. Let me draw the diagram for you guys so that you'll understand that where we are trying to creating and how it is going to route the traffic inside that. You will get some idea right now. Now first what we have to do, we just need to go for the draw.io right now. Yeah, so we can see that we have something, it is called as a region right now. This is nothing but like my region. And within the region, what we have something, it is called as availability zones. Yeah, I'm just trying to creating the two availability zones right now. This is one availability zone. Yeah, this is nothing but like another availability zone. Sorry. Oh, this is the availability. Sorry. This is nothing but like we have two availability zones. And here also we have the one more availability zone. Okay. Now here, listen carefully. Um, in this availability zone, we have created one. Let's say we have API hyphen South hyphen 1A. And here also we have one availability zone, API hyphen South hyphen 1B. Okay. Inside that, what I'm just trying to creating is we have something, it is called a public subnet. This is a public subnet. And here you have these two subnets we have right now. Already we have one private subnet. We should not create load balancer in the private subnet. It is has to be created in a public subnet. That's the reason I want to create one additional subnet inside this particular availability zone. That is nothing but like public subnet. I want to create it. So let me just do this right now, right away. We just need to go for inside the my networking. Here, go for the search for the VPC. Listen carefully. What I'm just doing is I'm just creating one public subnet. Now, if you just go for something, it is called as the routing tables. We have one route table already. Let me try to create a subnet. Click on the create a subnet, and we have to select the VPC. And here we have to go for the subnet name. The subnet name is Clahan hyphen. We can see about like public hyphen. I'm just trying to mention about like 1B. Now, which availability zone and AP hyphen south hyphen 1B. And we can see that this is where exactly your application is running. And the subnet IP address 10.0 dot, and we can see 3.0 and put the 24 is nothing but like CIDR block. And if we come down, we have to go for the click on the create a subnet. The subnet we are going to creating right now. Created a subnet, right? So once we created a subnet, after that, what we have to do is I just need to make you understanding about like we have to go for this particular route table, and there is a one public route table which we created. It has internet gateway. Now you have to go to subnet association. This route table associated with this only one subnet right now. I'm just trying to add in the one more subnet as well. This is 1B also. I'm just trying to adding it. Click on the save association. Now this is going to become a public subnet because it has the internet gateway. You want to verify it? If we go to the subnets, click on the 1B. If we go to the route tables, we can see there is something, it is called the one route table created and it has the internet gateway access. Now you go back to the load balancer. Now we have the two subnets. Now whenever you are just trying to creating the load balancer, the load balancer has to create here we have right now. Let me just go there. Here we have already one EC2 instances that we have. Here we have one EC2 instance. And if we come down, here we have another EC2 instances that we have. Okay. Now, whenever you are whenever you want to get the internet, we can see that one second. This is nothing but like my internet gateway. And this, let's assume that this is where you are gonna get the request. And from the request, this request will go to inside the, you can see that VPC. I forgot to create the VPC. Assume that this is the VPC line. Now we can see that we are doing everything within the VPC. I forgot to draw that VPC. That's it. From the internet, the request come to this first internet gateway. Okay. From the request, once the request come to the internet gateway, from the internet gateway, the requests go to the load balancer. You can see that this is my load balancer. Yeah, we can see this is the internet. From the internet, we can see that we are going to get the request to internet gateway. From internet gateway to it will go to the load balancer. Now from the load balancer, the requests go to your EC2 instances. Now right now we are we have only one instance where the application is running, so the request will go to this particular EC2 instance. Okay, if this application is running in this particular EC2 instance also, it is going to distribute traffic between these two instances based on the round robin algorithms. See, every load balancer, it has its own algorithms. Like we have the we have something it is called round robin. We have the list count. So I'll talk about in the tomorrow session more about the load balancers, what are the different algorithms it has, and we'll see about like how it is going to route the traffic, everything. Now, this is what exactly it is going to happen in the big picture. So load balancer is always request will go from the public subnet to the private subnet. Why we are creating this load balance public subnet means we require internet gateway. So whenever you send the request will come to the internet gateway. From internet gateway, request will go to load balancer. From the load balancer, the request will go to inside the subnet, private subnet. Again, how it will go, it means here we have a route table. From the route table, it will go request to this particular NAT gateway. From NAT gateway, request will go to the private subnet. Is this picture is clear? Anyone have any questions right now?
Yeah, it is
No.
clear, but load balancer is across availability zone, and there can be one load balancer in one view. Is it?
There is only one point that we have to understand. When you're trying to creating a load balancers, there is something it is called network mapping. Right. Let me just click on the create load balancer. Here we have to go for the classic load balancers. Now click on the create right now. And we have to provide the load balancer name. Let's say I'm just putting the Clahan-B. The scheme is internet facing. And if you just go for the VPC, we have to select the Clahan-VPC. We can see that select at least one availability zone and one subnet for each zone. Okay. And we recommended to selecting at least two availability zones. The load balance will route the traffic only to target in the selected availability zone, and availability zones that are not supported by the load balancer are not the or VPC are not availability for selections. What is exactly meaning is you have to select at least one availability zone where your servers are running. Now, where is our server is running right now? It is running on the availability zone 1B. We can see that we have two in this availability zone 1B. There are two subnets that we have. One is a private subnet and one is a private public subnet. Right. So we have to create load balancer on the public subnet. So you have to understand that wherever the availability zone where actually your servers is running, in that availability zone you have to select when you're creating a load balancer. Is this point is clear? Now in that availability zone 1B is my server is running. So I'm just going to selecting about the availability zone 1B. But the load balance is always we have to create on the public subnet. We can see that the Clahan hyphen, the public hyphen 1B. This is nothing but like where my load balancer, I'm just trying to configuring it. So if I don't select 1A also, it doesn't matter about it. But as per the recommendation, we can see that we recommended to select at least two availability zones. That is the reason only I'm just selecting about the other availability zone. Otherwise, there is nothing will happen if we are gonna selecting only one availability zone. My primary focus is I want to select availability zone. Where is my server is got running? That is very, very important. So load balances always sits inside the public subnet because it has the internet gateway access. If you look at the diagram, whenever you want to get the request load balancer, it will come to the internet gateway. That is the reason we have to create the load balancer on the public subnet. That is exactly we should understand that what is exactly it is. Now we need a security group, right? Now let me select the availability zone 1B, 1A. Here we have already public subnet, so I don't have any issues. Let me come down. We have to click on the security groups. Security groups is basically defines what kind of firewall that we have to open it is. This is other level of security that we are trying to add into your server. We can see I'm just created one security group yesterday. So same security group I'm just trying to creating over there. Now, see load balancer, it is going to expose with help of the port number 80. Listener is nothing but like load balancer listens which port number. That is nothing but like, 80. And if we come down, there is something it is called as health checks. I explained that load balancer will do two activities. One is it is going to check the health of the server. And the second one, it is going to accept the incoming traffic. It is going to route the traffic to the servers. That is what we are trying to understanding about this particular options, right? Now we can see that we have something it is called the ping target, right? See the health check ping, it is set using the protocol and port. specify you are using something, it is called HTTP and HTTPS. Now what I do, it is gonna send something, it is called ping request to this port number, and we can see it is gonna ping this vector path, the forward slash and index.html page. This is where it is going to ping the request. Right. Now we just need to go for the advanced health check on settings. Listen bit conscious here. Now what is meant by response timeout? We are discussing about like load balancer is going to check the health of the server. This is nothing but like my EC2 instance where my application is running. Right. Now here, very simple that we should understand. Whenever my load balancer send the ping request to this server, within how many seconds you want to get the response. See, for example, if you go to internet, you are send one request to your website. If you keep waiting for that, website has something it is called latency issues. That's very important point that we should understand here. Yeah, we can see that whenever the load balancer sends a request, this is nothing but like what is nothing but like it send the ping request. So within how many seconds I have to give the response to request? That is what we have to go. We can see that response timeout. Within 2 seconds, you want to get the response. It is your wish. You want to increase to 5 seconds. You want to increase to 10 seconds. That's fine, absolutely. But keep as low as so that the customers will not go to any other websites. Next one, we can see that interval. Interval is nothing but like how frequently I want to send the ping request to my server to check the status of the server. See, first, we just need to send the first ping request. We want to check the health of the server. The second also we are trying to send the ping request. We just need to understanding about like what is happening over there. This is something that we should understanding about like how your server it is trying to get the respond to your request. That's nothing but like ping request. See, ping request is always that we should understanding about like how we are going to get the respond to your request. So here, how frequently you want to check the health of the server, that is where we had to go for something it is called interval. See, first time when you ping, you are going to get the response. But second time you ping, you're not going to get a response. Then how we can know that your server it is going to be active status, it is running status? That is where we had to go for something it is called the interval. See, amount of time between health checks sent to the EC2 instances. See, for every 5 seconds, my load balancer has to check health of the server whether my server is going to be active status or not. This everything it is going to work in a background. You can't able to see with your eyes. But this configuration we had to do it because all these things will happen based on the algorithms. There is load balancer will use, there is algorithm called as a round robin algorithm. Round robin means like we should understanding about like first it is going to distribute traffic evenly to all the servers, so that's all the things will taken care by the algorithms. Now this is something it is called as the unhealthy threshold. See, we discussed about if any server it is unhealthy, if any server it is unhealthy, load balancer will not send a request to server. How it is going to determine that, or how it is graded that the server is and is going to be unhealthy? Let's say, for example, I have some emergency. I'm just trying to call into my friend. He's not picking the call, and I'm just keep trying for 4 to 5 times. See, definitely there is some assumptions come to your mind whether he's not feeling well, whether he is sleeping, or whether he's died. So something is happened to him. That is the reason he's not able to pick the call, right? That is assumption that we are just going that. The same way we have to understand that how we can able to detect that if the load balancer it is going to get the you're going to get these options right now. So first, if you just go to here, if you just come down, we can see that you have to send the first request. You're going to get the response. Again, what we can do that we have to send the another ping request. We can see that when if we are going to send two ping requests, if it is getting response, then we can determine that this is going to be like healthy status. The first time I'm going to ping the ping request, if I'm not getting response, If again I'm just trying to ping, if I'm not going to respond, then I can able to mark it as a unhealthy threshold. We can see that we have to go for something, it is unhealthy threshold. We can see the number of consecutive, the number of consecutive health check, the failures before declaring EC2 instance unhealthy. That is what we have to understanding about like what is meant by unhealthy threshold. So I said the target is 2. That means within two requests, if I'm not getting response from my server, then I can say that, hey, you stop sending requests to that, remove from my load balancer, so that I can understand about like, I want to send anything over there. That is where we have to go for something. It is called the unhealthy threshold. Now we can see there is something it is called the any healthy threshold right now. So whenever we go for something, it is called as a healthy threshold. So how we can define that one servlet is going to be healthy? I can't able to determine that with one request if my server is healthy. So I'm just trying to setting up the two requests here. See, first request will go to the server, the ping request. The second request also go to ping request. If both we are getting the response, then we can say about like the server it is going to be healthy status. That is something that we should understanding about like what is meant by response timeout, and we should understanding about like what is the interval. So I want to ask the question here, if anyone have.
No questions.
Make it fast. Yeah, I got two response, three.
Just a dumb question. So how
Yeah,
would we know what is a unhealthy threshold?
sorry.
I know that you mentioned like if you're getting more requests
No, tell
and
me
if
what
it
is it? Come again from the beginning.
no, I was just saying like when you said unhealthy threshold, like you're giving a number saying like if you're getting a lot of requests, if you're getting a lot of ping requests.
No, that is not what I'm asking about it. I'm not talking about traffic. I'm talking about the
Okay.
load balancer functionalities. You can see that it's clearly telling an
Uh,
above point. Your load balancer will automatically performs the health check to test
I'll check.
availability of all the registered instance. When I say
Yeah.
registered instance, nothing but like EC2 instance.
Easy to install. Okay.
Yeah, traffic only routed to the healthy instances, which determines on their response to the health check. So how it is going to check health of the server ping request. You can see that ping protocol it is using
Ping protocol.
HTTP,
Yeah.
ping port number 80. It is ping the spectral path. So first when I send the load balancer ping request to server, if the server it is going to give the response. See how we send the ping request right now. When
hmm
I go to my command prompt, sorry, PowerShell, if I use command called as a ping space, right? That's what I did it. Uh,
Yeah. Ping. You
yeah,
did ping space google.com. Yeah.
any IP address which we can ping. If we just go to ping
Mhm.
space, so it will convert into IP address www dot, let's say for example, google.com that I'm pinging. So we can see,
Mm.
look at my screen. This is nothing but like IP address of my Google server. We can see that it's showing about like it is healthy status. How we can know that? It is sent 4 packets, received 4 packets, lost 0%. The same way, my load balancer it is going to send the ping request to the server. So once it is going to send the
Okay.
ping request to server, then it will get to know that whether the server from the server I'm getting response or not.
Okay. So if there are no packet loss, then it's good. Okay.
Yes,
Okay. Okay.
great question. Uh, yeah. Now we have to attach our server to the load balancer. How we can able to attach that? We can see that you can add instances to the registered as a targets load balancer. Alternatively, after a load balancer created, you can add to the Amazon EC2 autoscaling. This we'll talk about later. I'll talk about only first point here. You can add instances to registered targets of load balancer. So now if you click on the add instances, in that particular availability zone, how many servers that are available that will show over there. We can see that in two availability zones, 1A and 1B, we have two servers. We have to select which server that you want to attach to your load balancer. I want to attach the web server. This is where exactly my application is running. You see, it doesn't have public IP address here. Now, that is the reason we are trying to creating load balance to expose to the internet. Click on the confirm right now. Confirm. And if we come down, we can see that attributes, we don't need to attributes anything. I'm just trying to click on the create load balancer. I'm trying to attach this server to my load balancer, and we can see that this is the configuration that we have to select when you try to creating a load balancer. Now click on the confirm and create a load balancer. Create a load balancer. Your load balancer got created. We can just look at my screen. So how we can able to access the load balancer? We can able to access the load balancer. We can see that based on the DNS name. This is a load balancer. This is a VPC what we have created. And we can see this is creating on 2 availability zones. And the type it is a classic load balancer. And we can see that we can able to expose with the DNS name. See, let me just go there. I just need to put it the new tab and Control V. Now hit the enter. See whether you are able to access or not. It is basically not HTTP request. It is HTTPS. Remove the S, hit the enter. See whether you are able to access or not. Now you are not able to access. I'll tell you what is the reason. Now, if you look at very clearly load balancer, if you observe that load balancer required to open the port number 80. If you just go to this options once again. Yeah. Load balancer, it is going to be exposed with the port number 80. Now here, you attach one security group. If you click on the Clahan load balancer, if you go to this option name, it is called as a security. Under that, you created what we attached one security group. Under security group, we can see that you have only port number 22, it is got opened. Now you have to add the port number 80 because it works on port number 80. Let me try to add rule. Go to here. I'm just trying to open the port number 80. So if we here we have to change custom to anywhere. IP4, click on the save rule. Once this rule is got saved, if you just go back here, now if you click on the refresh, and we can just look at my screen. 1 second. Control A, and we can just go back here, and we have to hit the enter. Now you are able to access the response. Even you guys also can able to access this website. This is a load balancer DNS name. Right now you can see whether you are able to access or not.
Yeah, I can access. It took a little time, but I think that's my issue. But yeah, I was able to access. Okay,
Is
now
it
it's faster.
accessible to everyone?
Yes, Murli, I can access too.
Okay, great. This is how you wanted to expose anything which is running on the private subnets. We can able to expose to the what we can say, we can expose to the load balances. You guys can try see every sentence, every concept that whatever that we're discussing about, it has a much depth. You have to sit and analysis and start doing it, make notes. So don't do it anything is the blindly. That's very, very important. Okay, so we'll start tomorrow. We'll see that how we can distribute traffic to the multiple server. Again, we'll come back to the load balancer concept tomorrow. I will explain about like what is L7, what is L4, and we'll see that how we can distribute traffic between the multiple servers. That we'll see in tomorrow's session. Okay. Yeah. Thank you guys. Thank you very much.